Good afternoon, my YouTube viewers. It is Crystal here. I'm here this afternoon because I wanted to do a code review. And in this code review, what we're going to do is we're going to talk about a t-test. So I wanted to go over what a t-test is before we do the code review. So some things that you need to know about a t-test is it is a type of inferential statistic used to determine if there is a significant difference between the means of two groups, which may be related in certain features. The t-test is one of many tests used for the purpose of hypothesis testing in statistics. Calculating a t-test requires three key data values. They include the difference between the mean values from each data set, called the mean difference, the standard deviation of each group, and the number of data values of each group. There are several different types of a t-test that can be performed depending on the data and the type of analysis required. So also wanted to talk about the p-value before we get started with this code, because a p-value is a statistical measurement used to validate a hypothesis against observed data. A p-value measures the probability of obtaining the observed results, assuming that the null hypothesis is true. The lower the p-value, the greater the statistical significance of the observed difference. So we've talked about the t-test and the p-value just to refresh your memory. So this is the formula for a t-test. So the t-test equals the mean minus the theoretical value over the standard deviation over the square root of the variable set size. So that's the formula for the t-test. And now we're going to go over some code, because obviously that's what you want to know about if you're going to be, coding. So, okay, so basically the first thing we do is we import the libraries of NumPy, Pandas, and Seaborn. And I don't know how that happened. I don't know how it even worked. But we import the libraries of NumPy, Pandas, and Seaborn. We set up ages. I have a bunch of ages, and these are going to be like people in college. So I set the lowest age of like maybe 13 and the highest age of 32. And then so we did a disk plot on that. So the great thing about the disk plot is it plots the ages, and then it also gives you a curve to tell you what the curve looks like. We calculate the mean of the age. Age mean equals NP mean ages. So the mean age is 22.5. And then what we do is we set a sample size of 10. So of that array of ages, we only want 10. So age sample equals NP random.choice, ages, sample size, and then age sample. So we have 10 ages in this age sample. So we do a disk plot again, and then so you can see the sampling of the ages. And the great thing about the disk plot is it plots the variables on graph, and it also gives you the curve, tells you what the curve looks like. Now what we're going to do is we're going to do our t-test with one sample. So from skippy.stats import t-test one samp. T-test one samp, you ask the age sample and 25. And so the age sample I think is 10, and then 25 is another variable that they want. Oh, the age that you're looking for. So the t-test one sample result is The statistic is negative 1.4 and the p-value is 0.17. So we checked it again for an age of 15. So the statistic is 4.9 and the p-value is 0.0008. We checked it one more time with 20. The statistic is 1.7 and the p-value is 0.118. So we're going to do another example on this. And so we do import NumPy as NP, import pandas as PD, import skippy.stats as stats, import math, and we import seedborn as SNS. We do NP random seed 6. So what you want to do is you want to set it up from 6, because if you don't set the seed up, then what's going to happen is every time it generates a random number, it's going to be different. But if you set the seed up, then it'll be the same seed every time. School age equals stats.poison RVS. LOC equals 18, mu equals 35, size equals 1500. Class A age is stats equals stats.poison RVS. LOC equals 18, mu equals 30, size equals 60. So we print the school age and print the class age. So you've got your school age and your class age. So your class age is your sample, your school age is your population. So now what we do is we print the school age mean, which is 53.3, and the class A age mean, which is 46.9. And then so we do a t-test one sample, class A age, and then school age dot mean, and that gives you a statistic of 9.6 and a p-value of 1.13. And so now what we're going to do is we're going to do dash p-value equals t-test one sample, class A age, pop mean equals school age mean. And they'll say if p-value is less than 0.05, then you reject HO, otherwise you accept HO. So that's just basically a demonstration on how you can use a t-test. I mean, I'm still learning statistics, and because I'm still learning statistics, I can't tell you everything that there is to know about it, but this will just tell you how you can do it in Python if you want to set up a t-test statistical model in Python. So I'm going to go ahead and close this presentation. If you like this video, please like, subscribe, and share. And I want to thank all of my subscribers for supporting my channel. Thank you so much for watching this video, and I look forward to making more videos for you in the future.